So we plug in 4. So we get 20 minus 16 plus 64. And then minus when we plug in 1, 5 minus 1 plus 1. And we can get that number, right? Okay. Next problem. The integral from 1 to 2 from 2 over 1 plus x squared minus 5 raised to the x minus 2 over x dx. So if we finish, and we can come back and determine this number if you want, and then determine this number. But I like to move on to cover everything. I would like to talk a little bit about this 5 to the x, okay? And then we'll put everything together. So remember when we differentiate e to the x, what do we get? Perfect. But when I differentiate 5 to the x, I do not get 5 to the x. What do I get? 5 to the x times the one that is 1 here. Because we have to change the base. And by changing the base, that's what happens. So now, when I integrate 5 to the x dx, what will I get? Something that when I differentiate, I get 5 to the x. Exactly, so it goes away. Exactly. So when I differentiate this, I have 5x natural log 5, and it will go away, and I get 5 to the x. So when we come back here, and when we integrate this, the answer will be 5 to the x over natural log 5. When I differentiate 5 to the x, I have 5 to the x times natural log 5. Okay, so let's do this together. The integral from 1 to 2 from 2 over 1 plus x squared. Well, remember 2 goes in front. It's just a constant. 2. What do I get? Which function prime is 1 over 1 plus x squared? Perfect. arctangent x, awesome. Then minus which function prime is 5 to the x? Exactly. And then minus 2 is a constant. Which function prime is 1 over x? But the absolute value, as we discussed last time. Natural log of the absolute value of x. From 1 to 2. You could say, fine. But since it's from 1 to 2, you're going to have to drop the absolute value. I agree. I will. But still I have to put it in. Why will I drop it? Because it's between 1 and 2. And that's always positive, right? Everything is positive. But I have to have it initially. So then, I plug in 2. 2 arctangent 2. I have no idea what that is. I'm going to leave it as is. Minus 5 squared, which is 25 over natural log 5. Minus 2 natural log 2. So this is the result when I plug in 2, the upper limit, minus. Let's put everything in parentheses now so we don't forget to distribute -1 to all of them. 2 arctangent 1 minus 5 over natural log 5. And how much is natural log 1?
0.
Very good, times -2 is 0. So you can write 0. Only one I can calculate here, which is this. The rest I can't, unless I approximate them. I know an angle whose tangent is 1. If tangent is 1, its sine and cosine must be the same. Which angle is that? Exactly. So that's the only one that I can replace. Everything else has to stay. So I will write 2 arctangent 2 minus 25 over natural log 5 minus 2 natural log 2 minus 2 pi over 4 will be pi over 2 and plus 5 over natural log 5. And you can combine these two into -20 over natural log 5 and leave everyone alone, everything else alone. There is no point in trying anything here. Just replace these two by -20 over natural log 5 because there is the same denominator. Other than that, you can leave it alone. Okay, the integral from e to u over 1 plus e to u squared du. What do you recommend?
Substitution.
Yes. Say it again.
X.
Yeah, if you want, or y or u, it doesn't matter. Not u, I'm sorry. Y or t. What would you like to get rid of?
1 plus.
Exactly. Especially for two reasons. First of all, it's in the denominator. And if I have two terms or more in the denominator, I can simplify. And furthermore, it's inside x squared, basically. Okay, so now let's see if we are on the right track. How do we know whether we are on the right track? If dy is in the problem, or can easily be made. So dy equals? U?
Times du.
Exactly, awesome. So then this is quite nice. This piece is dy, and this piece in the denominator is?
1 over y squared.
Exactly. So now the new integral becomes dy over y squared. What function prime is 1 over y squared? We had it a minute ago. Yes.
First.
Yes, -1 over y plus a constant c. Since it's an indefinite integral, I must go back and replace y by by what?
1 plus
E to u plus a constant c. Awesome. The integral from cosine to the fourth sine x dx. Okay, 1 minute. It's not a lot left. We also looked at 7. Any suggestions on this one? Okay. Let u be, bless you.
sine x.
If I use sine x, then I will have, bless you, I will have difficulties with this. I really want this to disappear. Sine is friendly, but cosine to the fourth is not really friendly. So I will say, let u be,
Sine x.
yes, cosine x. Is du in the problem? Almost. Negative sine x dx. I don't have any problem with making up a negative 1. I multiply by negative 1 twice. So then what will I say? That this is the same with what? U to the fourth. And what will this be? The negative sign, the sine and the dx. Very good. So this is negative the integral from u to the fourth du. So negative u to the fifth over 5 plus a constant c. It's indefinite. I have to go back to negative cosine to the fifth divided by 5 plus a constant c. Are we okay with this? Yes? The integral from 0 to 3 from 1 over 2x minus 1 dx. Any ideas? Any ideas?
Substitution.
Okay, substitution is one option. What do you think? What did we say? That every time we determine a definite integral, what do we have to check first?
That it exists.
If the function is continuous. Is this function continuous between 0 and 3?
Yes.
It's undefined at 1/2. It couldn't be continuous between 0 and 3. So what do we conclude? Calc 2. Fundamental theorem of calculus not applicable. Function is not continuous on the interval 0, 3.
So on the test, is that what you want to?
That's it. You don't have to write Calc 2, but you have to write fundamental theorem of calculus not applicable. F of x is not continuous on 0, 3. The integral from -π/6, so please always remember that. Because this theorem is not applicable. It's like, for example, any of the theorems that we applied, like intermediate value theorem, right? Like mean value theorem, like Rolle's theorem. If the conditions are not fulfilled, I can't apply the theorem. Good. So let's work. Yes.
What does it stand for in FTC?
Fundamental theorem of calculus. What do we notice here?
Check for symmetry.
Yes, because the interval is symmetric. Every time I see an interval that is symmetric, I always check whether the function is odd or even. If the function is odd, the answer will be
0.
perfect. If the function is even, the function will be, the integral will be
2 from
twice the integral from 0 to π/6. I prefer twice from 0 to π/6 versus -π/6 to π/6. You saw how difficult sometimes it is to plug in those numbers. So if one of them is 0, I'm really happy for that. Very good. So our function is, so this is, I write symmetric interval. I have to write that. And then I have to say f of x equals x squared, or write this, and then find f of -x, which is -x squared times sine -x. But what is -x squared? Still x squared. But now I have to remember, is sine an odd function or even? In other words, does this equal sine x, or does it equal the opposite of sine x? Exactly. So it's an odd function, and that makes the whole thing odd, -f of x. So odd function. So what do we conclude? For, yes. So please keep that in mind. Now for number 5, do you want to work on this for a minute? Or you can say we just looked at a problem like this and I don't want to. You can work on it with a table if you want. Or say no. Which one?
Let's give it a shot.
Okay. I think we do have time. I just want to make sure that we cover everything. Okay then, so then the function is, we cannot determine the antiderivative of this. Don't even try. So the integral from 0 to 8, sine the square root of x dx, and obviously the interval is 0 to 8, and we want n equals 4, with the midpoint rule. So remember what I would do. I would present this interval just to make sure I don't make a mistake, and I will divvy it up into 4. So this is 2, 4, 6, and obviously the midpoint is 1, the midpoint is 3, the midpoint is 5, and the midpoint is 7. And the width of the interval is? Yes, b minus a divided by 4. So a divided by 4 is 2. So the area with M4 is 2 and multiplied by f of 1 plus f of 3 plus f of 5 plus f of 7. That's all I have to write and just calculate. Is this okay? So in the calculator, I will put in list L1, 1357. But in list L2, I will write 2 times sine square root of list L1. Because that's what we want to calculate. And let me know what you get. I'm going to put it in the calculator as well. Let's see what I get. So 2 multiplied by sine, make sure that you have the mode in what?
Radian.
Please. Let me know what you get.
I have 6.182.
Exactly, that's what I got. Here it is. 6.1820. Agreed? Yes? Matt, you need any help with that? Okay. So let's look at number 6. We are given v of t, which is 2t minus 4. We are given the closed interval 0 to 6. They want two things, displacement, and number 2, total distance between 0 and 4. So what is the displacement?
Or sorry,
The displacement is the function.
t squared minus 4t.
Yes. So plus a constant, right? So the displacement is s of t, the integral from v of t dt, which is the integral from 2t minus 4 dt, which is t squared minus 4t plus a constant c. But now the total distance, what did we say? What was the total distance? What is the formula for the total distance? Total distance equals the integral from 0 to 6. I have a pencil for you, so you don't have to worry about that.
My pencil ran out of blood.
That's okay. Let's see. I hope that this one works.
Thank you.
You're welcome. The absolute value of 2t minus 4 dt. But we can't determine this before we work on the absolute value, correct? So we have to take the absolute value aside and present the two options and then find the integral from the absolute value. Okay, so then we have two options, right, for the absolute value. One option will be 2t minus 4, and the other one negative 2t plus 4, correct? From the absolute value of x being x for x positive or negative x for x negative, correct? So for t greater than or equal to 2 and for t less than 2. Is this clear? If it's not, I will explain again. So all I did was follow the pattern for the absolute value. So if this is 2x or 2t minus 4, this is 2t minus 4, and this is the opposite of 2t minus 4, which will be negative 2t plus 4. If 2t plus 4 is positive, but 2t minus 4 is positive, greater than or equal to 0, I move 4 divided by 2, and I get this. So now I know what to do with and how to find the total distance. How do I find the total distance? Yes, the integral dx plus the integral dx. Yes, that's the whole purpose of this. We've done this in chapter 2 with that particle going back and forth, but we did not know integration then. We just determined the absolute value of each piece. But now we know integration. So, what is the first one?
From 0 to 2.
Very good.
Function is negative 2t plus 4.
Awesome. And then from 2 to 6, from 2t minus 4. Can you give me the number for this one?
20 feet.
We determined 20? Everyone agrees with 20? Do you trust Tom? I do. Do you? Should I calculate it? Yes? Should we check his work? Okay. So negative 2t squared over 2 will be negative t squared, and plus 4t, this one from 0 to 2, and the other one will be t squared minus 4t, but this time from 2 to 6. In the first one, I got lucky because there is 0 at the bottom, so I only plug in 2, negative 4 plus 8. But here, I have plus 36 minus 24, but minus when I plug in 2, and then minus I have to distribute, plus 8. So these 3 go away. Then this is 44 minus 24. I agree with 20. Well done. We did this problem last time, so let's look at the extra credit and then find more problems from anything that you would like to review. So the question is, find the derivative of the function. Of course, the limits of integration are not numbers. So no one can ask us to do anything else but just differentiate both sides. But can I? Is it ready for differentiating? Is the right-hand side ready? Remember, we need a constant at the bottom. So we have to split the integral into the integral from 2x squared to any number you want. What number would you like to use?
0.
0 it is. T squared over 1 plus t dt plus the integral from 0 to tangent x t squared over 1 plus t dt. This is good, but it's not ready yet. I have one more step before, so one more prep.
You do all that first, and go by negative.
Yes, in other words, once I change, reverse, I should say, or swap the limits of integration, that becomes negative in front. There is a negative in front, yes. So this is negative the integral from 0 to 2x squared, t squared over 1 plus t dt, plus the integral from 0 to tangent x, t squared 1 plus t dt. And now I differentiate the left-hand side, and let's see what we get on the right. So can anyone tell us the derivative of this? How does it look?
The negative 2t to the fourth over 2.
So 2x squared squared, because I have to square 2 as well,
Yes.
right? Over 1 plus 2x squared multiplied by,
I did the inverse.
that's okay, multiplied by,
4x.
very good, plus tangent squared x over 1 plus tangent x multiplied by,
Secant squared x.
that's it. Yes, I will rewrite it one more time in the sense that I will multiply these. So this is 4x to the fourth times 4 will be 16x to the fifth. But I will not do anything else. So 4x to the fourth times 4x is 16x to the fifth. But nothing else can be changed. Okay, we still have a few minutes. So I'd like to go back to any type of problem that you would like to work on. Any type. Anything. Maybe an inequality, maybe
Riemann sum.
another Riemann sum. Very good. Let's choose a function. You choose the function, you choose the interval, anything you want.
Something in the second power or something.
Okay, so let's say f of x equals 2x squared plus x plus 3. And the interval, if you want to be,
0.
yeah, if you want to be more relaxed, you'll use 0. If you want more, difficult, slightly more difficult, you'll put any other number.
0, 3.
0 to 3. Okay, so please remember we need the 3 preps first. And then we put everything together. What I would do immediately, I would definitely find the integral on my own with definite integral. Just to make sure and have an idea of what to expect. I shouldn't say on my own, you know what I mean. Find the definite integral first. Just to see what I am looking at. Not because I'm trying to, anticipate anything, but it's good practice to check. So I will do it first. It will not take long, especially because it starts at 0. And we said that the checklist would be due also Tuesday, okay? Can anyone give us the three preps?
Finding delta x, b minus a, which is 3 minus 0 over n.
Good.
over n. And the next one's xi, which is that's going to be 0 plus I delta x.
Which is 3i over n, very good. And 3, f of xi. What do we get for f of xi? 2, 3i over n squared plus 3i over n plus 3. But we need to simplify it before we put it in the limit of the Riemann sum. So I see that this is 9 times 2, right? 18i squared over n squared plus 3i over n and plus 3. So now I put everything together. Did we determine the area, the exact area with the integral from 0 to 3 from 2x squared plus x plus 3 dx?
It's 54.
54? Yes, did we get 54?
39.
Okay, so let's try. 3x cubed over 3 plus x squared over 2 plus 3x.
Or I copy down x to the x cubed instead of x squared.
So this is 27 plus 9 halves plus 9. So 54 plus 9 plus 18. That's okay. So 54 plus 27. So this is 81. I got 81 over 2. Is that correct? Oh,
Is that 2?
sorry, I copied 3. Sorry.
18.
So 27 divided by 3. Yes, it will be 18. Thank you. So 18 times 2 will be 36. So 36 plus 27. 63 indeed. Is that 63?
Yes.
Yes? We got 63 over 2. Okay, so now the area with the limit of the Riemann sum, limit as n approaches infinity from, I put in front 3 over n, and now I have 18 over n squared times the sum of I squared plus 3 over n the sum of I plus 3 the sum of 1. This is the most complicated one because it's n plus 1, 2n plus 1 divided by 6. This one is n plus 1 divided by 2, and this one is n. So this is limit n approaches infinity, 3 over n. So 18 over n squared times n plus 1, 2n plus 1 over 6, plus 3 over n times n plus 1 divided by 2, plus 3n. Limit as n approaches infinity, 3 over n. And now let's see. If I simplify, I have to simplify an n for sure. But if I simplify 6, then I will still have a 2 in here. So the least common denominator, I will only simplify by 3. And the least common denominator stays as 2n. And only this one needs a 2n. So I will be distributing 6 to these two terms, two factors, but I will multiply first. This is 2n squared plus 3n plus 1, and I'll distribute 6. 12n squared plus 18n plus 6 plus 3n squared plus 3n plus 6n squared. So limit n approaches infinity, the denominator is 2n squared 3 times 6 plus 3, 9, 21. 3 plus 12, 21. Now plus n squared, of course, plus 21n and plus 6. And the leading coefficient is 63. The leading coefficient at the bottom is 2. And we did get 63 divided by 2, as we expected.